The next step in wells is we'll look at the a basin and see different hydraulic effects on the water that might be in a basin. So this would be a cross-sectional view of a valley with a stream. And within this valley, we're going to have a water table that will sit at a given level, at stream level, on the shallow surface water table. Water would penetrate into these surfaces and seek its level on the water table and be used in that area. Then get up here into the mountains with this thing and see what could happen if we put a confined layer of rock in here. Well, we have a layer of, in this area would be basalt. In this part of the country, it could be granite in other parts of the world, or other subterranean rock. And we might have a rock barrier. We call this an impervious layer. So any water that is coming down and leaching into this area is going to run the surface down and finally catch up to this water table, and then this area down here is going to be saturated. So as we get penetration of water into the soil, it hits this layer, it hydraulically is always moving downhill due to gravitational pull, and it's going to work its way into this surface water table and be collected. Now what's going to happen is water that's penetrating in up here is going to find a different zone to fill into below the impervious layer. And it might have a water table that sits right at this level. So as it comes in, it will fill up this water table. And so all of this below this impervious layer is full of water. See how that could happen? So we'd have a lava flow, then we could have porous rock again. Now, what is this? Well, this is fractured rock usually. And it might just be a band of water that's in there. And again, we might have another impervious layer. You know, we might have another band of water that comes in, or a rock layer that comes in here, and this stuff is just gathering in here. You get the idea how we can have an area, basically an underground stream or an underground layer of water waiting to be used. Now sometimes there will be an underground layer of water like this that's not getting recharged at all. It'll be called a fossil water. It'll simply be water that was trapped in the eons while the earth was being made, and it's just sitting there waiting to be used. As soon as it's used up, it's gone. Under the whole peninsula of Saudi Arabia, that's effectively what's happened. They had a big pool of water underneath that country, and as they pumped that water out, it was not recharging for anywhere else. It was old fossil water, and they just used it up, and now there's very little water left in a lot of the regions of that country because it was just a depleted resource at the time. Just like as they pump oil out of the ground, they're depleting that resource. They did the same thing with water.
Would that be good quality water, that old water?
The old water, quality-wise, could be any variety of water known. Sometimes it's good, sometimes it's not so good, depending on the minerals that are in it. It's not going to have bacteria in it, so that's not good. It's not going to be contaminated that way, but it could be contaminated by minerals. Could have high sulfur, it could have iron, calcium, things like that.
Bless you.
Thank you.